Здравствуйте. Yay! Я Скат. Я твой американский друг. Я не понимаю по-русски. That's pretty much all I know how to say in Russian. So this is machine learning for designers. This picture is a Buckminster Fuller building on fire, and it's very deep and symbolic in that machine learning is the death of modernism. And so I want to talk about machine learning, and I think it's really important for me, and it's really important for you guys to learn about machine learning, basically because you are the most qualified people to design machine learning models and algorithms and products that involve machine learning. Human-centered designers are extremely important, and I think that the role of design is really to defend humanity. It's to defend other humans against the capitalists, basically, that don't care, the indifferent capitalists. So a little bit about me. I work for I'm the head of UX for a company called LPK. I write for a Fast Company, and I am a teacher at University of Cincinnati DAP, Design, Art, Architecture, and Programming. I live in the middle of Cincinnati. That is this stereotypical American town. Before that, I was at Adaptive Path out in California, and we were the first UX design firm in America. And about 4 or 5 years ago, we got bought by Capital One, and I spent like 3 years there, and it was fun. So most of the stuff that I developed in this talk is from Capital One and Adaptive Path. So it's a lot of, it was developed in a bank, basically, where there's a lot of data. So we're going to start off back in the day. So this is one of the very first computers. So it was developed by the US Navy. And this is what the New York Times wrote about it then. New naval device, learns by doing. And they also called it an embryo, which is really weird. But they expected it to walk, talk, see, write, reproduce itself, and be conscious of its existence. So that was a very long time ago. That was back in the 1950s. Obviously, that didn't happen. But all of the math and all of the technology that we are using for machine learning and artificial intelligence right now was created back then because that's what computers were originally supposed to do. So this is one of the very first neural networks. It works actually the very same way neural net machine learning works, except it's made out of wires. So the reason we couldn't do this back then is because we didn't have computers anywhere near as powerful enough to do it. So now we can, and now we're doing machine learning, and that's why it's so popular now. So what is machine learning? So it's really important that we know what it is as designers. So a very simple definition of machine learning is improving performance in some task with experience, but that's pretty vague. This random guy on Stack Overflow had this answer. It's a method of teaching computers to make and improve predictions or behaviors based on some data. So that's pretty good, but it's basically just software that you write with data, and you just feed it a bunch of data, and it makes the software instead of us telling it what to do. So what's different about machine learning and traditional code? Well, traditional code is explicit. So we give it very specific instructions, telling it exactly what to do. Do a lot of people here write code, real dynamic stuff? Yeah, you know what it is. You have to tell it exactly what to do, and if it doesn't do that, then that's a problem. Whereas machine learning is different, and it is implicit. So basically what you're doing is you're writing software that makes predictions, but instead of writing explicit code, you're just feeding it a bunch of examples of what you want it to predict, and then it predicts something, if everything goes well. So here's the basic process. It's software that's written by showing it data, then it makes predictions. So we have our data, and we build something that's called a model. That's a machine learning model, and that's something that is, it's really, it's best to think about it as just a piece of software, just like any other software. And then it goes inside of a bigger software application that we're going to design as designers end to end, and it's just a small part of it. It's just a little piece of software. Some examples of how machine learning is used very popularly right now. Classification. So image classification, you guys will see this on different social media networks where it suggests tagging a friend in a picture. Here's one from Google with one of my pictures. And basically, the prediction here is a 0 to 1 N, and it's a confidence level. So it's 94% confident that that's an aircraft, 93 airline. I was actually really impressed that it got boarding. Like, that's sharp. That's good. Another one is regression. So the Yandex navigation application, all that stuff, it's basically just making predictions where the output is a number. So if you guys learned in math class, it's the same thing. It's regression. It's making predictions, and the output is a number. And then there's clustering. So it's a really good example. So Amazon in the US, they always say, okay, so if you like this item, you're going to like these other items. And it's basically just showing things are related to one another with a whole bunch of data. So if we wanted to do that with every single item in like Alibaba or Amazon or anywhere else, it would be impossible, because every order you would have to like add a little bit more weight to these items and say that they're a little bit more related. So it's basically just scaling up things that you could have done, but they would be impossible at scale. One of the biggest things that I want to impart for designers, at least, is that if you cannot do machine learning, if you can solve a customer problem without using machine learning, you should do that. Here's a really good example of Google's Gmail thing, where it asks you if you forgot to attach something. You could do this with machine learning. You could label a whole bunch of different emails and say, okay, so here's this is what it looks like when someone meant to attach a document to the email, but then they forgot. Or you could just write some code that says, if there's the word attach in there and there's nothing attached, then show this thing. So if you can do it without machine learning, do it without machine learning. That's really important. Okay, so when I do this with my students, I have them do this little exercise to kind of help out. So I'm going to do this. Everybody just kind of do this in your heads for me. So this is pseudocoding, where it's like, pseudocoding is where you write code without getting any, sorry. So you write code without code, and you just kind of describe what it's supposed to do. So describe step by step how you would brush your teeth. I usually give them 5 minutes. But brushing your teeth is something that you can describe in like with line by line by line. It's like a procedural thing. You put toothpaste on a toothbrush, you put it in your mouth, and you move it around. And then I trick them, and I say, okay, so now I'll give you 5 more minutes, and I want you to describe step by step how to recognize a human face. And this is a really good example of something that you can try, and I want you to, in your head, try to make a step-by-step instructions on how you can recognize a human face. It's very difficult. So that's something that machines can do, machine learning can do really well, but humans can't write instructions on how to do that. Okay, so I think about machine learning in 2 different ways. The first is machine learning as design material. So this is where we talked before about how we have the data and we train that software and that becomes a model. So when you have machine learning as a design material, then you will, at that point, what you're doing is you're using someone else's model. So there's a lot of different examples about this, but it's basically when you're using it in your software, but you're not using your own data. So examples of this, various facial expression meters that will tell you. So this one, she's very happy. It's like 99.5% sure that she's happy. So like expression software that can recognize if people are happy or not. That's something. Here's Amazon. They have a service that you can use called Recognition. It's just another one of those object classification things. So these are out of the box, and you can just use these as your service. It's very cheap. You basically rent a model that someone else trained for you. Here's Google's version of it, Google Cloud. So Google has a Google Cloud platform. I suggest everybody kind of get into this. It's really fun. Give it a shot. But it has things like Cloud Natural Language API, Speech API, Translation, Cloud Vision API, and they're all free to try at least. When you want to incorporate them into a huge product and you're pinging these models like 100 times a second, then it costs a lot of money. But if you're just kind of messing around and building a prototype or something, you should definitely try these different services. Okay. So the more important one, and the type of machine learning as it relates to design that is much more interesting to me, is machine learning as design architecture. So what that means is that you're actually using your own data, your user's data, to build a machine learning product. So what does that look like? Here's an example from wearable tracking, wearable device stuff. So what we have here is a target variable and input variable. So in machine learning language, the target variable is the one that you're looking at and you're trying to change. And then the input variables are the context for that target variable. So what we're going to do is we're going to say, okay, so our current state is right here. I'm getting 5.5 hours of sleep. I want to get much more sleep. My goal is all the way up there at 8. So I have a whole bunch of data. And I know that I'm down here, so I can analyze what I look like. There's going to be a lot of variables, a lot of pieces of data that aren't going to matter. So first thing is we clean the data. We get rid of those. We figure out a handful of things that are actually valuable. And activity, what time you went to bed, how much alcohol you consume, and how much time you spend at a bar. So this is a personal example. So if you don't get a lot of sleep, it turns out you can just do these other things a little bit differently. But these are all of the factors that give context to the main data point that you're trying to affect. And so basically what you're going to try to do is you have an example now at the next level up of exactly how someone acts who gets 6 hours of sleep. So basically what you're going to try to do is move all of these variables into that other space, and the assumption is that if you do that, if you live like someone who gets 6 hours of sleep, then you too will also get 6 hours of sleep. So I think that's for behavior change, and this is machine learning for behavior change. This is very useful. And you go to 6. Okay, so very quickly I want to jump into the design process. How are we going to do this? Once again, design does this, all right? So we pick the data, we figure out what data is relevant, we can help build the model, and I'll show you how to do that. And then it's just a small part of the software. So the first part is to get hands-on with the data. And what I like to do is pay a company to build a Tableau dashboard. It's just a business information data visualization tool. I don't know if that's popular in Russia, but there's all kinds of different data viz software that you can have developers use APIs to build for you. But basically what you want to do is you want to have your design team, so people who are not engineers, you want them to be able to have access to this data. And it has to be visualized, and it has to be something that they can understand. So put it in Tableau and make it accessible to the designers. Next part, sketching. Here's a weird example of some sketching. Here's some stuff that I was doing when I was doing data analysis. Sometimes machine learning model sketching literally looks like this, where you're just kind of like, all right, looks like if it was this % full. Okay, this is really hard to explain, but sketching looks like that. I can get into that later if you want to come up afterwards. But then it ends up, this is actually a planned out machine learning model that I sent over to data scientists, and they eventually made one from that. Okay, so now I want to talk about ideation very quickly. So I still think of machine learning, and I think it's useful for all of us to think about it as a black box. On one side, when you're ideating for these kind of things, what you're going to want to do is think about, if it was a human, how would you tell them how to do it? What are the goals of the human? What are the input variables? So what's the data that you have that is relevant to what you're trying to do? And then what is the target variable? Then, on the outside, you have to think about what output you're expecting. So when you answer these questions, you can write all these things down and then give them to an actual data scientist, and they will tell you if you're crazy, if this just isn't going to work because that's not how the data works, or they'll say, oh, that'll work. I'll build a model, I'll train a model, and we'll see if it works in our software. After that is called dialogue or conversation. Right? So basically what we're going to need to do is design a conversation between the model that we're building and the user itself. And we need them to give us input on our model. And I think it's useful to give them direct input on the thing. So we ask them what kind of goals they want to achieve, what are their preferences, and have them answering questions, and then literally giving them access to manually adjust their model. And I'll show you what that looks like. Here's one of Google's models of me. This is everything that Google thought I was interested in about 4 years ago. So it was all of these things, and if you really dig into your settings as a user, you can find this stuff and actually go in and delete things. Like, if I'm not into, I don't know, men's interests, I have no idea what that is, so I can delete that. All kinds of things. But you give them direct access to the model, and you let them choose whether or not that model of their behavior is accurate for them. Another thing is this. Another example from Google is just a really simple, dumb question like this. Is this card useful right now? It's showing you this stuff, and then it gives you the easiest thing to answer. And then that goes into that model. Is it useful right now? No. And then it looks at the time. Okay, so maybe he likes the content, but it's not the right time. Okay, or it's maybe she doesn't like the content, and it is the right time. So they figure it out, and then you just do it over and over again, and then it learns. Then there's implicit feedback, which is basically just feedback from behavior. So they adjust their behavior. That means you're doing it right if it's the adjustments that you're trying to make as a designer. Or if they stop using your product, that's also some good feedback. And the big thing, though, is transparency. So all of this really just kind of comes down to transparency. So what we're going to do is demonstrate decision provenance. Tell them where you got the data. Always tell them where you got the data, or they won't trust you. Show a confidence score. So like we said before, be like, this model is like 95% sure you're happy right now. And then show the next couple guesses when you're trying to classify. It's like, oh, you might be a little sad, though. I don't know. And then don't speak in absolutes. Don't just say you're happy, you're sad, or this is a bike. Here's an example of that. Once again, confidence score here. Netflix does it. Let's see, 99% match. Really quickly, how do we prototype? We do it with taking actual data and faking it. So basically, what I would do at the bank is have people actually bring in their bank statements and their spending information and have them literally hand it to me, and then I hand it to one of my designers, and they prototype something and then bring it back, and it's basically the Wizard of Oz methodology. All right, and that's it. All right, we're ready to open it up for...
Do we have a throwing box?
So, are we going to start our Q&A section?
Yes.
Great.
We only have 3 minutes left?
Okay, let's start a little bit. Yeah.
Okay.
Let's start a little bit earlier. So, you see my microphone is working.
I know, how'd you do that?
Yeah, I don't know. So, thank you very much. That was really great. So now, let's give applause one more time, guys. And now we're ready for the questions.
Oh.
Yeah.
8:20, yeah. Here.
Look, such fun.
So, so thank you for presentation. I have one question. So I want to try machine learning.
Yes.
And should I work with data scientists? But I don't have data scientists in my company. Or I can try to use it myself. So find some APIs and try it myself. Can I try it myself? This is my question.
Yeah, so I think I talked about the two different types of machine learning. One of them being machine learning as design material. And that kind of stuff is when you use other people's models. You could do that without a data scientist, a very expensive data scientist that can make machine learning stuff. But I think if you're going to want to use the real user data, like your user data from the product, it's going to be very difficult, and you're going to have to pay an actual data scientist. I think from a design process, though, you can get a lot of the way there. It's just there are no tools right now that I'm aware of that it would make it easy for someone who's not a data scientist to actually build a useful model from their own data.
So if I want to make some model, I need a data scientist in my company for my case. Yeah?
Yes.
Yeah, thank you. Thank you very much.
Thanks.
Scott?
Yes.
Perfect. So, actually, it's kind of connected to the first question.
Okay.
So, how far are we from models, like making other models? And is this the beginning of the end? Pretty much for humans.
Yes. One, it is the beginning of the end. And not just for design, but for humanity. But I think we are somewhat close to making models, and I think some models are easier than others. So I've been messing around with some stuff that Google has in beta right now, where you can do image classification with your own images. So you can like, basically what you would do is, if I wanted to recognize people's hair color, and I would basically collect a whole bunch of pictures of people with red hair, and like put that in a folder, and then blonde hair, put that in a folder, blue hair, put that in a folder, and you upload each one of those folders and say, all of these pictures has a person with blonde hair, all of these person has a picture with blue hair. Then the model will start learning what those look like, and that one actually works, but that's really the only one that I found that's kind of an off-the-shelf thing where you can use your own data.
Hello. Could you provide one example of how your design decision was based on some machine learning algorithm?
Yeah, well, I mean, the design decision wasn't based on the machine learning algorithm. The machine learning algorithm was based on the design decisions. So one example is I've been working with a appliance company a lot lately, and one of the big things is they want to have appliances do things without people telling them to do things. So basically, we were designing ways that information would be collected that would be useful for the people who were living with these machines, that the machines would do the right thing. I have to be purposely vague, I'm sorry. But yeah, so the first thing that my team did was to design the data collection, which is a big part of design. I think will be a big part of design in the future for this kind of stuff. You design what data you need, and then you design software to go out and get that data, to then build a model that you're going to use. But then after that, what you're going to do, basically what happened was we figured out, and I can show you these sketches. So this was one of those things where we looked at a whole bunch of data that people had that we went out and collected, and we figured out that something happened when one appliance was over 55% full versus when it was equal to or less than 55% full. So we were like, okay, so that's usually when they do that thing, so we can do it for them at this time. However, that only happens on weekdays. On weekends, it's very different. And when they do it, the latest time that they do it in the day is this time. The earliest time that they do it in the day is this other time. So basically, when we had to figure out with machine learning what the best time was to do this thing, and this is how we started sketching. We were like, will this information give us what we need, and will that information actually be make the right output for the person who's using it?
Thank you.
One more? Yeah.
Thank you. Do you think through machine learning design will be evil?
I think technology might be evil in the future. I think, so there's a big difference between like machine learning and kind of general artificial intelligence, and I think that's what's going to be evil and potentially kill us all. So we talk about, I think just like machine learning, like what I'm talking about here, is just another design tool, and it's nothing magic. But when we have the point where the machines are smarter than humans, I think that'll be a little bit different. So I think that what could happen is once machines start gaining general artificial intelligence and they can start working on each other, and they can like rewrite their own software to be better and better and better, and they can already do that better than any human, basically the development curve of how smart they get, instead of going like linear like this, it just goes straight up. So basically, in theory, there could be 100 million years worth of advancement in like 5 minutes, and they might just get bored and kill us all. Who knows? It's a coin flip.
Depends on the purpose, because machine learning, the goal of machine learning is to understand people and give them what they want, but in a way to trick them to get what they want.
Yeah, I think that's a possibility, and I think that's why we as designers need to be more involved, because I guess it's just an assumption that designers won't do that, and companies will. But yeah, I mean, I think that in the wrong hands, it could make it easier to scam people. Yeah.
So just one small question. Yeah, short.
Okay. Continuing on one of the previous questions, do you have experience of machine learning in actual design decisions? For example, analyzing the user behavior and making some design decision based on results of machine learning?
Yeah, no, I haven't done anything like that. You mean like changing like a layout or like doing optimizations on software like individually? No, I haven't done that. I think in terms of design, how things work and why they work is a little bit more interesting and accessible right now. A lot of people talk about that as a potential thing that would say like, that would take all of our jobs away from us. But I don't know, I just don't think that's super interesting, and I don't know what kind of weird software that would make. I just don't know if that will work. It might be terrible, it might take all of our jobs, but I haven't seen a good implementation of that ever.
Thank you.
Thank you.
So, thank you, Scott, one more time. Thank you for your question, guys.